Hello, math humans. We're going to do 4.3a today. We're going to be talking about right triangle trig. Our objectives are that we're going to do more work with special and non-special right triangles and then some calculator work. So I've written a couple of things down just to get us started. So remember, for right triangle trig, the sine of theta is y over r. We used to say so opposite over the adjacent. Now we use big kid math, y over r. Cosine is x over r. Tangent is y over x. Okay, and if you'll notice, that means that tangent is also sine over cosine. So that's kind of cool. The cosecant of theta is the reciprocal of sine, and I remember it that the letters don't match, so it's going to be r over y. Secant is the reciprocal of cosine. Again, the letters don't match, and it's r over x. The cotangent of theta is x over y because it's the reciprocal of tangent. If we're talking about coordinates, we're going to be talking about xy. We're also going to be talking about cosine theta, sine theta. Okay. The next thing that I want to remind you about, we talked about this in PreCalc, but you've talked about it in other classes, the Pythagorean triples. So Pythagorean triples are a great time saver. So if you remember these are the ones that are the most common. So if you'll remember, the Pythagorean theorem is a leg squared plus a leg squared is equal to the hypotenuse squared. So these are some combinations that satisfy the Pythagorean theorem. That's why we call them Pythagorean triples. And if you remember these, then you don't have to show math. So for example, if I did 3 squared plus 4 squared, and I wonder, is that equal to 5 squared? So I would get 9 plus 16 is 25, and 25 does indeed equal 25. So it's really important. You don't have to memorize these. They are just something handy to know to save some time. All right. So now let's jump into our first example. So for example number 1, it says find the 6 trig ratios. And we're going to be given a right triangle. And we know that this is theta, this is 3, this is 4. Well, because this is a right triangle, then this is a Pythagorean triple. That means you automatically know that that's 5. And again, I could test it. 9 plus 16 is 25. 5 squared is 25. So then if I want to do the sine of theta, notice the way that our triangle is. It's going to be y over 5, which is going to be the radius. My cosine of theta is going to be 3 over 5, and the tangent, scoot it up so you can see, the tangent of theta is 4 over 3. Then I do my reciprocals. The cosecant of theta is 5 over 4. Secant of theta is 5 over 3. And then the cotangent of theta is going to be 3 over 4. So those are actually pretty easy to develop. All right, so now let's do a little bit of calculator work for our second example. So for example number 2, we're going to do a little bit of work in your grapher. So as I bring in my grapher, and I go to my mode button, and I think you can see that. So if you'll notice, my calculator is in radians. My calculators live in radians because in big kid math, radians is the expectation. But there will be some problems where we need to switch to degrees. So it is very important that you check the mode of your calculator before you actually start doing a problem. So the way that you know, sorry, brain and mouth aren't working at the same speed, about whether to use degrees or radians is based on the units in the problem. If you have the degree symbol, that means this is degrees, and so I would put my calculator in degrees, second quit, and then I would do the cosine of 28, and then I would write down my value, and it's 0.8829, so I'm going to write 0.883. On the other hand, if you see something like this, the cosine of 2. notice that there is no, sorry, bad grammar, degree symbol. That means then that this is radians. So we typically don't write the word radians, but the assumption is if there is no degree symbol, that means that the angle is in radians. So to do the cosine of 2 radians, I go back to my mode button, put my calculator in radians, and I do the cosine of 2 and hit enter. Okay, and notice that you get a negative 0.416. Also pay attention that we always write down 3 decimal places. All right, so for example number 3, it says sketch the triangle and then evaluate, if I can get my computer to stay with me, the 6 trig functions, okay? And we're going to be given that the cosine of theta, I can't see it, cosine of theta is 5 over 6, okay? So I'm going to go ahead and sketch my angle in standard position. So a couple of things to notice. Remember that the signs in the first quadrant are positive and positive, meaning that cosine is positive and sine is positive. In the second quadrant, x is negative and y is positive, so that means cosine is negative, sine is positive. In the third quadrant, I have negative and negative, which means that cosine and sine are both negative. And in the fourth quadrant, I have cosine is positive and sine is negative. So technically, if I drew cosine in standard position, it could be either in this or this, but because this is positive, that means that we're going to put it up here in this particular quadrant. I could also do this quadrant, but this is the standard location, so that's why we're going to start here. So cosine is x over r, and then that means that there's theta. I don't know y, so I'm going to have to find y by using the Pythagorean Theorem. So 5 squared plus y squared is going to equal 6 squared. Y squared is going to be 36 minus 25, which is going to be 11. So y is going to equal the square root of 11. Technically, it is plus or minus, but in the first quadrant, sine is positive, therefore I'm going to write down the positive square root of 11. Well, now it's easy to come up with my ratios, okay? So the sine of theta is y over r, so it's going to be the square root of 11 over 6. Cosine was given, so I don't need to report cosine. The tangent of theta is y over x, so it's going to be the square root of 11 over 5. The cosecant of theta is 6 over radical 11. You do not need to rationalize the denominator, and actually my preference is that you not. I know that's a little bit scandalous. Secant theta is going to be the reciprocal of cosine, so it's 6 over 5. And then cotangent theta is the reciprocal of tangent, so it's 5 over radical 11. So that was actually pretty easy. All right, let's do example number 4 as I get my pen ready, sorry. So for example 4, that almost looks like a 4, I want to find the value of theta, I think you can see that color, without a grapher. And that's going to mean you're going to start seeing the word exact. If we're not allowed to use our calculator, that means that we're going to look for exact, and we're going to be given that the sine of theta is 1 over 2. So again, the first thing that I'm going to do is I'm going to draw my triangle, and I'm going to label sine as positive in the first and the second quadrants, but we're going to start here. So I'm going to do 1 and 2, and then I need to find x. So x squared plus 1 squared is 2 squared, so x squared is 4 minus 1, which is 3, so x is going to be radical 3. And again, in the first quadrant, x is positive, so I'm just going to write that little radical 3 right there. Okay, So then it says find the exact value of theta. Alrighty, well, I actually didn't need to do all that work, but opposite the 1 is a 30, and so we write in radians because radians is the default. So theta is pi over 6. I didn't need to find x because I could have done it from here. I just did it for posterity. All right, let's do our next example. Example number 5. And it says find the value of theta without a grapher, so I'm going to write exact. And then we're going to be given that the cotangent of theta is radical 3 over 3. So before we start the problem, I'm going to manage this ratio. So the cotangent of theta is radical 3 over 3. It is easier to manage this problem if you unrationalize. And if I unrationalize, this is going to be 1 over radical 3. And so basically what I did is I divided each term by radical 3. So it just is nice and easy to recognize because this makes our specials easier to figure out. Cotangent is going to be x over y. So that means that when I draw my little triangle, right, x is 1, y is radical 3, which means that the hypotenuse is 2. Opposite of radical 3 is pi over 3 because that would be a 60. So theta is going to equal pi over 3. You can see that it's really important that you have those special right triangles memorized because we're going to need to use them often. Alrighty, that is it for today. I will see you soon.